afternoon. There's a lot of you, so let's get started. I don't have much time. This presentation takes usually about 45 minutes. I have half an hour, so I'll need to be quick. That means that you will be able to download the slides, and I will be a bit fast on them. So if you just subscribe to my Twitter account, I will publish them there. So I assume that, how many devs are in here? Well, are you all familiar with Stack Overflow? Yeah, okay. So, okay, let's get started then. So this talk is about architecture. So architecture is a scary word for a very simple thing. You have a problem, you need a solution. And when you code, there is a small problem which needs a very specific solution. Architecture is about large, big problems and big solutions. So that's what I'm going to talk about. And in particular, if you want to talk about the architecture of a website, you need to talk about how simple or how complex and how big or how small the site is. That's the first thing. That's your problem that you need to solve. Yeah, so let's size up the problem. So Stack Overflow, you said you're familiar with it, but actually it's part of a larger set of sites. We are 120 sites. We have almost 6 million active users. This means users that actually answer the questions, not so registered users, and who are active. So we delete all users. We have around 10 million questions and 10 million answers. So the numbers are not huge, but they are big enough that you can't just do whatever you want. So 120 sites. This is a small selection of them. As you can see, we do much more than simply computers. We do RPGs, English, cooking, Christianity. What else is there? Photography, game development, and so on. I mean, there is a bunch of sites. They all run on the same software. So, of course, the software needs to solve the problems for all these sites. Overall, as a network, we are number 55 in the world. So that's a pretty big achievement. What that means, that in particular, in Poland, we're number 13, according to Quantcast. So thank you. And what it means in practice, so what really worries us, or makes us feel really cool, but also worries us, is that we need to do this every month. Yeah, we need to serve 500 million web pages. So again, not Facebook scale, but not your average web app. So how big is our data center, right? Other companies with similar traffic, maybe they go in the hundreds of servers. This is our data center. As you can see, there are about 20, 30 servers there. Most of them is disk, because there's a lot of contents and questions and answers. In practice, this is what we have. So we have 25 servers serving all of the Stack Exchange assets. 2 in front here are 2 load balancers. Basically, they load all the requests coming from you, the wonderful unicorns in the cloud. They go here, and then this shuffles the requests among these 11 web servers. And then they have all a set of support backend services. There are 2 Redis, 3 Elasticsearch, 4 databases, only two of which are active. And we have a tag engine, which is a separate indexing service that we have to discover questions by tag. So it's a very, very small number of servers. And you may imagine that these servers, since we keep them so small, they're very, very busy. But in fact, they're not. So if you look at this is an actual screenshot or a composition of screenshots from our web farm. And as you can see, most of the servers are below 20% CPU. Yeah, this column here. There are these 2 here, which are 27, 25, because they were taking backups. So I took this shot at night. And so that's why they're a little more busy. As you can see here, these database servers have a lot of RAM. Yeah, that's not disk. So 384 gigs of RAM. Yeah, But they're not very busy. In fact, we calculate that we could potentially run on 5 servers only, which is pretty good achievement at the moment. It actually happened a couple of months back. We screwed up some caching. We released a new version, and it had a wrong if statement. So we disabled the cache. 9 web servers went down like straight away, like lead, bonk. 2 stayed up, and they kept up all the load. People didn't really notice. It was just a bit slower. So it is possible that we run on 5. Right? So all in all, we are still scaling up. So many companies say, oh, fine, we scale out, we shard, and we don't do any of that. We are very, very compact and monolithic, if you like, but still scaling up. This is to say, it's important not to underestimate how much work can modern servers do, especially with almost 400 gigabytes of RAM. So the first thing I'm going to talk about is our development lifecycle. So how do we get there? Yeah. So the second part of the talk. First of all, we have an interesting development lifecycle. First step. So what we do is we get feature requests. They come from the community, from product managers, from our own minds, and we develop remotely. So almost all the developers in the core team are work from their bedroom or a separate room. So that's why we call it a bat cave. Of course, I couldn't find the bat thing, so I put the Spider-Man one. But OK. And I don't really use a Spectrum. I used to use a Spectrum in the 80s, but not now. It's a real computer. So first cycle that we have is in here. It's a very, very quick cycle. Obviously, you build, you test, everything is fine. Once everything is fine, it's just a git push and continuous integration. Well, this wonderful 90s invention. The interesting bit here is that we deploy, or the code is automatically deployed to a site, which is called dev.Stack Overflow. And it runs on the same servers. So not on clones, not on a separate development server. It actually runs on the real thing. So we can test a lot of things in terms of integration. Does it work on 11 servers or 2 servers or whatever? Does it work on the real databases? So this gives us a guarantee that whenever we want to deploy this, the deployment is going to work pretty well. Once it works there, it's pushed to a canary site. A canary site is just a single site out of the 120 which gets special attention. So it gets all the new versions. It gets many, many different versions every day. And the users on that site are warned, and they know that that site is more fallible, if you like. So there can be bugs. And if they find any bugs, they tell us, right? Oh, we forgot to publish the style sheets. Everything looks like crap. So, but if not, right, with one click, we can push it live. And then, a ton of people use it, and then they can provide new feature requests. So it's a big cycle. So this is not that different from what a lot of companies do. I think in our case, the big difference is that we are not afraid to move fast and break things, like Facebook does, but probably even faster. In practice, we deploy 5 times a day. So the choice we made is to keep the barrier to deployment very, very low. In fact, so low that we can do it multiple times a day. That means that we are not afraid of introducing bugs or screwing things up. Because if we do, just one click, everything goes back up. And we do screw up things, apart from the homepage. Another thing that we do to be really, really fast is we do a lot of caching, obviously. So this is a quick schema about how our caching layers work. We have a network level cache. This is our CDN. We got per server caches. So stuff that is in this cache will be singularly for one instance of, say, a particular site on a particular server. And then we have a distributed cache based on Redis, which basically keeps all the cache in memory, shares it across different 11 different web servers. If stuff is not found there, we hit the 384 gigs of RAM. And then even if we don't find anything in there, and this is the reason why we have so much memory, we hit the disk. So there is a lot of different layers and a lot of different steps that can happen before we actually read something from the disk. This obviously makes everything faster. But generally, how many of you have worked on caching before? A few. Is it easy or is it hard? It's hard, right? Because there is multitasking, locks, invalidation, right? So let me talk a bit about how caching works at Stack Overflow. So this is the Help Center. It's not a particularly known page, but it's like a CMS, right? So there are a lot of articles, and they explain how to use the site, and so on. So this is the code that actually fetches the articles. And as you can see, it's 10 lines of code. It's not more than that. It's super terse. So what you can see here is, first of all, there are basically no layers. So we use MVC. This is a model. We use static methods, global objects, so all stuff you should never be doing, and don't do it. So this is the global cache. This is getSet method, means basically try to get this, the resource identified by this cache key. If you don't find it, you execute this. This is our data access layer, 2 lines of code, which what it does is just runs SQL and puts stuff into objects. That's all that there is to it. It's just as minimal as possible. Okay, so if you look, each line adds information. The first line here, global cache, says, okay, I'm going to look for a global cache. So this stuff is going to be common for all the sites. The second line means, okay, I want you to get me this help posts list. And if you don't find it, then this is what you need to do. This identifies what it is. And these 2 lines is database access. I think you can't get really much terser than this. You can probably remove some brackets. So the reason why we can get this terse is because we use a lot of libraries. We build a lot of libraries. And this means that we write code. Once we find it's very, very stable, we release it, and it gets out of our code base. This keeps our bug count low, because stuff that is shipped, we never touch again. And once we know it doesn't have bugs, it doesn't have bugs. And then the code is so simple that it's really hard to screw it up. So cache all the things. But the speed or hitting the database or an external resource is not the only reason why we do caching. There are actually more reasons. One of them is garbage collection. Are you guys familiar with garbage collectors? Not so much, huh? So, okay, so that's why I have this slide, haha. So this is the most complicated bit, so hold on, yeah? We can do it. So what is the garbage collector? Basically, in languages like C# or Java, you can allocate new objects by saying, hey, I want a new car or whatever. And when you don't need it anymore, when it goes out of scope, then it gets the memory allocated gets automatically deleted. So there is a process behind that when you say new, allocates the memory, says here's the new object. And when you don't need it anymore, it takes it away. And this is the garbage collector. What it needs to do, it's really complicated for it to determine and run time when something is not needed anymore, so it can safely put it away. So in order to do so efficiently, it keeps everything in a stack here. And at regular intervals, or when it gets too big, it's going to go through it. It's going to block everything, like a global lock on your application. It just stops. Goes through it and sees, OK, these are the root objects. These I know that I need. And this is what the dependencies they have. So it goes through and looks for all the objects which are in use. All the rest, gone. And you get to this. As you can see, this operation can be quite complicated. So Microsoft says 2 things about the garbage collector. Well, it says more than 2 things. This is just a selection. You don't need to read it because it's too big. But basically, the titles. If you create too many objects, then it's a problem. And if your objects are too complicated, then it's a problem. So let's talk about the first one. And we use caching actually creatively to actually go over that problem. Because remember, we serve a lot of pages. So we create a lot of objects. 500 million pages means at the very least 500 million objects to be created and reclaimed by the garbage collector. So what we're, just to recap, imagine this is a garbage collector. These are all your objects in it. It took me ages to put them in. And as you can imagine, it's like this, right? It's like a risotto dish. If you want to pick one seed at a time, it's going to take you a long, long time. And that's what the garbage collector does with this. So we want to avoid this. We want to avoid the risotto thing. So when we have a page which is very, very popular, this is probably our most popular answer, you need to cache things which are not obvious that you should be caching. So these 3 tabs on top are 3 links. So it's a very simple thing. Their contexts do not come from the DB. Their contents are simply hard-coded strings, okay? There is nothing in them that needs any caching because it's too slow to build. In fact, this is the code, right? So this part here, all it does is creates 3 verbatim simple objects. Okay, this is an enum, these are literals. Okay, this is all, there's no calculation in there. This act of creating these objects is super fast. But if you look on top, whoops, we are caching it. Why? Because this page makes maybe 95% of the requests of the 500 million. So caching it is much slower than creating them, but we are actually fetching them from memory. So we keep 1 copy of those objects. We don't need to create them for every page view. And this keeps the number of objects created much lower. So we don't have the risotto problem. Yeah, so we abuse caching for performance. Another thing that we do, so the second problem with garbage collector is creating too many pointers, right? So basically, if you have too many pointers, something like this happens. So what that means is that you have objects which all depend on each other, and it's really, really hard to say which ones actually do not depend on any external root. So if you were to take this and tell me, okay, which of these shapes have no lines tying them to the external ones? It's really hard to say, but there are a few. Yeah, so it's like a dish of spaghetti, and you're trying to eat one at a time by pulling them off. It takes a long time. So in order to avoid these kind of problems, we need to avoid things like this. This is inversion of control. It's a very fairly standard technique. It's used principally in testing, and is used to create decoupled application. So basically, you have an object called a container that knows how to build other objects. So when you need an object, you go to this guy and say, hey, give me an object of this type. And he goes, OK, I'll build it for you. And you use it. Yeah, it's very, very simple, right? Stirs, it's simple. The problem is that typically with IOC containers, what you're actually doing is doing some form of aspect-oriented programming. You're actually creating a number of different pieces that validate your data, that cache it, or that control security and access, and so on. So in practice, this is what gets executed at runtime. So it's a series of different objects, one created, nested inside the other, or dependent on the other. So this is really, really bad for a garbage collector. So we don't do dependency injection. We cannot use IOC containers. That would be like playing really badly with our system. So how do we do testing, right? How do we guarantee quality? It's a big issue for us. So our source code, we have very, very few projects. Actually, we have one less because we killed this API. And we have very, very few lines of code. Both of these things happen for one reason, because we use libraries. Libraries get done, tested, and moved on. So they're not part of the projects. They are not part of the lines of code that we maintain. Unfortunately, we have very, very few tests because we can't use inversion of control. So for us, automated testing is a problem. But we have a great community to help. So who are our users? They are developers. Who is a better tester than developers? So we created this canary site, our users, so developers go there, find the bugs for us, and mention them, and then we get all the bug reports. That's way better than automated testing. We have automated testers. Why is it better? Well, for example, if there is a JavaScript bug or a CSS bug, typically, not only I get a great bug report, which is not like, oh, it doesn't work, whatever, but it's like, actually, these are the repo steps, and this is how you do it. But you actually get the patch. Yeah, because developers say, oh, it's a problem. Here's how you solve it. So, I mean, try to do that with unit tests. So that's how we can get away with having so few tests. So key takeaway here is you're not going to need it. Key architectural principle. We try to do the minimum amount possible that we can get away with and use our own circumstances. Hey, we have a great community of developers. Let's use them. They're happy. We're happy. So a little bit more about libraries. So why are libraries so important? Well, libraries are important for a number of reasons. If you use unit tests, typically unit tests have a side effect. And the side effect of unit tests is that they exercise the public API of your DLLs or of your classes, right? So you have your classes, and then there is some test which actually uses the class. So if you change the signature of the class, for example, you have to change the unit test. So they make it harder for you to change these things. This is not a bad thing. This is actually a good thing. And it's a good thing because you want to have a stable, well-crafted, clear, unchanging interface. That's what you want to have. Which makes it really hard to code, but it also makes it very, very good once you nail it. So we don't have unit tests, but we release our software or our libraries as open source. That means that once they're in the wild and once people are using them, if we change the signatures, it's not some unit tests getting upset, but some users getting upset. And that obviously makes us unable to change the things. So we have to think really, really well about what we do. So another thing is about this, about reinventing the square wheel. It's an Englishism to say that you're trying to make, so you want to build a bicycle, and you want to create a new wheel which works better than the old wheel. But hey, a lot of people have thought about the wheel, and your wheel is going to end up like this one. Yeah, so you're going to be really, really unhappy. So we reinvent a lot of wheels, and we need to make sure they're not square. In practice, that they are something like this, right? So this guy is a mathematician that calculated that if you use a bicycle with square wheels, you're going to have a great time going over this kind of hyperbolic cosine road. And that is perfectly smooth, right? So we try to, yes, build square wheels, but when we actually need square wheels. And these are a few of our square wheels. These are all open source software. If you do .NET or JavaScript or maybe Ruby, you could have used some of it. Some of it is platform independent. For example, Observer is this dashboard that I showed you with the servers in the beginning. It's a .NET project, but it runs by itself. So we do this all the time, as I was telling you, because we want to make sure that our code is well crafted, is used by a lot of people, is tested by a lot of people, and we can't change it. So we know when we release it, we must know what we're doing. So key takeaway here is wrap code in libraries and open sources. If you can do this at your company, do it. It's great. I've been doing it at ScienceChange. I've been doing it before. It always worked out great for me because you have to think before you build classes instead of just following some recipe. Then finally, speaking about recipes. Every company or every architecture needs to have some secret sauce, right? Like a chef. And this is not particularly about coding, it's more about how we do things. And I think it's fairly important in understanding why all the rest works. So, first of all, the team. So this is our team, this is my team. As you can see, it's maybe, what, 30 people? Out of these 30 people, only a third actually work on Stack Overflow, on the code. A lot of them do great things, like manage the community, or do design, or make sure that our servers actually work. But only 10 do the coding. It's a very, very small team for such a large top 50 site on the internet. So we wanted to have a small team of friends, of people that can work together, of people that are all smart enough to do their best. Well, they don't look smart enough here, but. Another thing is geek culture. Do you know who these guys are? Microsoft. So this is Bill Gates, right? Okay. Who's missing? Palmer, right? So geek culture. You want to have a culture which is friendly to geeks. So you create these tight teams of people who are really cool and can really code, and then you have a culture which is hostile. Another company I worked for, they really didn't like developers. They came up one day and say, okay, we're not a software company anymore. We are a network company. And then guess what happened? All the best developers say, okay, bye. So you need to be friendly to developers. And then what do? You need to allow them to do what they like to do. Yeah, be nerds. Yeah, so IL, this is like the machine language of .NET. Yeah, everybody tells you, oh, don't do that, it's too hard. Well, it's pretty hard, but we do it. Why not? It's a challenge. You know, if you can pull it through, do it. We do it all the time. Deep dives also are in queries. So, for example, you know, monitoring what your database is doing. Other things, hire the best players, hire the best developers. You know, not everyone is the right fit for your company. Not everyone has the skills. You know, sometimes it's just a matter of fitting the right skill to the right job. Don't hire people just because you want someone. Hire the best you can find. In fact, that's the reason why we hire remotely. I could never have worked for Stack Exchange if I had to move to New York, which is where our headquarters are. I am from South London, south of London. And so about half of my colleagues from the core team, they are not at all from the US. Only 2 are from New York. Other thing is tools. Again, you hire super geeks that are very, very good at what they do. And then you don't trust them to tell you that they need ReSharper, or they need the new edition of Visual Studio, or Sublime Editor, or whatever. A lot of companies do that. This is unbelievable. It's like you're debating with the developer whether it's worthwhile spending $300 on a stupid license or on a new monitor because they think they can be more efficient. Tell you what, what's really inefficient and what's really expensive is debating these things, not buying them. Just buy them. And that's what we do. We have a policy. No questions asked. So key takeaways. I'm running a bit long here. So there will be no time for the questions, by the way. If you have any questions about Stack Overflow, we have a desk just outside. I'll be there until 5:30, so just come and haggle me as much as you want. So first one, whoa. Performance is a feature, right? So this is one of our principles. So if our size goes low, it's a bug. Yeah, think about that. It's not only a reason to, you know, something we can improve. No, it's a bug that we need to fix. Second thing, always be shipping. Remember, we ship five times a day. Lower the cost to shipping. That means making bugs less expensive. It means being more responsive. Third thing is user circumstances. That means we got great developers as our users. We use them as developers. You don't really need to do the same as we do, but you need to understand the scenario in which you work and what are your points, the things you can leverage in your architecture. Open source your libraries, very, very important. Make sure that it's no bullshit, right? You don't write shit code just because it's internal. Don't do that. Yeah, write world-class code and release it so you get actually proof. You're kept on your toes. And finally, tools. Give the tools you need to everyone because it's really, really important and you don't want to have a great team just to get them upset all the time. So that's about it. Thank you very much for coming.